In 1.3, we're going to talk about describing quantitative data with numbers. A lot of this stuff that we're going to talk about, especially at the beginning, is going to be super familiar because it's very, very basic stats that you may have learned even all the way back in like 3rd, 4th, 5th grade. Okay, so we have ways to measure center. First one is the mean, okay, the average. It's exactly what you think it is. You add up all the numbers and divide it by the number of numbers there are. Okay, one thing that I do want to point out to you here is, because it's going to be super important throughout the year, is this symbol. Okay, we call that X bar, and X bar is the symbol for sample mean that we will use throughout the year. Okay, so here we have, how to calculate the mean. You guys probably all know this. Okay, but I want to point out in this data, the mean is 3.15. And we have these two potential outliers out here that are much larger than the rest of the goal scored numbers. Okay, so if we take those potential outliers out, then we get a mean of 2.44. So it's about a half a goal difference if we take out the outliers. So what you need to know about the mean is that it is not a resistant measure of center. And what that means is if there are outliers, the mean is going to be largely affected. It is sensitive to those extreme values, whether they are lower or higher. So that means we need another way to measure center. We'll use mean, but we'll also talk about the median, which is the middle of the set of numbers if we arrange them in order. Okay, so again, middle of the numbers, if we have 2 left over, then we find the average between those two numbers, and that is the median. Okay, the median is a resistant measure. It is not too affected by outliers. Okay, and so for that reason, we need to be able to compare the mean and the median. Okay, so if our distribution is skewed to the left, the mean will be pulled down by those low outliers, so it will be less than the median. And then the opposite is true. If our distribution is skewed to the right, our mean will be pulled up by those higher outliers, and so it will be higher than the median. If our distribution is roughly symmetric, our mean will be roughly equal to the median. Maybe not exactly, but they're going to be pretty close. Okay, so this is that same information in words instead of a picture. Okay, so that was measuring center. Now we're going to measure variability. So one way we can do that is the range. Very simple, highest number minus lowest number. Okay, the range is not resistant, just like the mean, because if I change the outlier number, then my range would be much smaller. Okay. Something else that measures variability is the standard deviation. Okay, definition of standard deviation, something you should know. It is the typical distance of the values in a distribution from the mean. So how far are all of the numbers from the mean? Okay, you see this formula here. I don't really make you guys use this, but I think it's helpful to understand what standard deviation is based on the formula. So we're taking each data point. That's what x1, x2, xn. Like if I take those soccer games, it would be 5, 5, 1, 10. Those would be all my different x1s, x2s. And we're going to subtract them from the mean. So we're going to figure out how far away they are from the mean. We square that distance to make it positive, and then we divide by n minus 1, the number of numbers minus 1. And then we take the square root at the end because we squared all of these numbers. Okay, so it's sort of the average distance. Okay, we use the word typical instead of average, distance that every value is away from the mean. Okay, I'm going to show you how to get this on your calculator in a little bit because this formula is long and messy, and we have the technology now that we don't need to do that by hand too much. Okay, some notes about standard deviation. Okay, it always has to be greater than or equal to 0. The bigger it is, the more variation we have in our data set, and it is not resistant, again, because it can be pulled by outliers. You also have to be able to interpret the standard deviation. And so you do not have to memorize this sentence word for word, but you got to get the gist of it. Okay, so we say the context, whatever we're talking about, typically varies by whatever the standard deviation is from the mean of whatever the mean is. Okay, so here we have this information about the height of NBA power forwards. And so if I were asked to interpret the standard deviation, my sentence should go something like, the height of power forwards in the NBA typically varies by 1.52 inches, always include those units for context, from the mean of 80.1 inches. The third way that we can measure variability is something called IQR, interquartile range, okay? And so you may remember doing box and whiskers, all right? We're gonna call them box plots now, but box and whisker graphs, where we had Q1 and Q3, and Q1 is just the middle of all the numbers that are below the median, and Q3 is just the middle of all the numbers that are above the median. If we find the difference between those two values, Q3 minus Q1, and again, I'll show you how to get those on the calculator in just a second, that number is called the IQR, or interquartile range. Okay, so here, Q3 is 42.5, Q1 is 15, we subtract them, that's my IQR. Okay. Now, all of those things I just talked about, they all will be listed in the one variable stats function on your calculator. So you have directions, whether you have a Casio or a TI, we enter the numbers in the stat function, and then we get the one var stats, and it will show you the mean, the standard deviation, the median, the quartiles, the minimum, the maximum, all of that information all right there on one screen. Okay. The next thing we want to identify is outliers. So hopefully you have noticed we were talking about all the things that you should describe when you describe a distribution. So the center, the variability, and now the outliers. Okay. There's lots of different rules for outliers. The most common one, and the one that is used most often in AP stats, is the 1.5 times IQR rule. Okay, and so what we do there is we find our IQR, and then any number that is lower than Q1 minus 1.5 times IQR is an outlier. And any number that is higher than Q3 plus 1.5 times IQR is an outlier. Okay, so here we have an example. Here's our information, and IQR is 0.4 miles per gallon. So I'm going to take my Q1, which is 22.2, minus 1.5 times 0.4, that gives me 21.6. That means any number in my data set that's lower than 21.6 would be considered an outlier. Then we do the same thing for the high outliers. This time we're adding to Q3, right? So any number higher than 23.2 would be considered an outlier. Okay, so that means this dot right here at 21.5 and then this one at 23.3. Those are both considered outliers. When you're asked about outliers, you need to show this math and then name the outliers. So like everything from, you don't have to write low and high, but everything from this orange line down, that would need to be included in your answer. Okay. Another method that you might see looking for outliers is either the 2 standard deviation or 3 standard deviation method, but we can talk about that later. All right, box plots, aka box and whisker, which you have seen before. We need to be able to do a quick sketch of these, and so to do that you need what's called a 5-number summary, which is the minimum, Q1, the median, Q3, and the maximum. All of those are on your one var stats page. Okay, and your calculator will also make a sketch for you, and it's super easy to get the numbers on the calculator and then draw a number line and sketch those 5 numbers. Okay, so here are your directions. It seems like long directions because first time you do it, you have to set up the box plot settings in your calculator, but after that, super quick. Okay, and so basically you're gonna follow these directions, get some numbers, all right, and then when we sketch it, find the 5-number summary. The calculator is going to tell you if there's any outliers. In AP Stat, we always mark outliers separately, all right? So we're going to draw a number line, okay, and scale it to the data that we have, okay? Our box goes from Q1 to Q3. We put a line in the middle for the median. We draw whiskers out to the min and the max as long as they aren't outliers. Okay, if there's outliers, then we just go to the next number that's not the outlier. Okay, and then we mark the outliers usually with little stars or dots to show them separately from the box plot. Okay. All right, now box plots are nice. They can tell us kind of the shape. They can show us outliers. Things that they can't do, all right, is they can't show us each individual value. So here we have this dot plot layered over the box plot. So on the dot plot, I can see all the different numbers. If I just have the box plot, I can only kind of see the general areas, okay? They also don't show you if there are any gaps or clusters or peaks in your data, okay? So what graph we make is always dependent on what information we need, all right? And that's it for 1.3.